Welcome to the chapter notes for chapter 12 as we look at cost curves. We're going behind the supply curve to look at inputs, look at costs, and see what impact it has on economic decision making. Thanks for joining me. So what are we going to look at in this chapter? Well, we're going to look at inputs and outputs. We're going to look at the costs associated with them. We're going to look at how we end up with diminishing returns on what inputs we're using and how we're getting less and less from them. We're going to see how that's calculated, looking at the marginal cost as well as the average cost. We'll show you how to differentiate between those. We'll also look at the short run versus the long run and the differences between those two in terms of how that affects resources. And then also economies of scale and diseconomies of scale, the role of technology in changing how we use resources and how they can be helpful and used in bringing down costs, but only to an extent. And then we start to see what we call diseconomies of scale, where costs start to rise again. There's only so low that you can go. Even Walmart can only go so low with prices, and then you have to move forward. So that's what they're looking at here. We start by looking at the production function. This is the relationship between the inputs that a firm uses, how many of those, and the outputs that it is going to produce. So what inputs are you putting in terms of what you're creating, and what's the output? What's the production function? Think of it like an assembly line. You have inputs, resources that are going into creating cars. You have resources and you have all kinds of variable and fixed resources that are going into creating these items. And then you have output. You have output in terms of resources that are being produced, the cars that are being produced as part of this. And so all of this is very much like an assembly line. That's really what a production function is this assembly line of inputs, resources going in to create something. Think of it like the Chipotle, the food bar at the Chipotle restaurant. You have all kinds of inputs, all kinds of resources that are going into creating that burrito bowl, but you decide what goes into it, just like you decide what goes into your car. Very much a production function. Now let's look at differences between these inputs, this idea of fixed versus variable. A fixed resource is something that doesn't change no matter how many items you're going to produce with it. So this could be things like if we were in class, we'd be creating an assembly line using a table, a desk, using scissors, using staplers, and we would create this production assembly line, which is always a fun activity. Unfortunately, in this environment, we can't use it. But the idea is these are fixed resources. They're not going to change. They're not going to be used up as a result of producing one quantity of this item. We're going to see we can use the table or the desk again and again. And the same thing with the scissors and the same thing with the stapler. We can use these items over and over again. We're not just using them up once we've used them. And then variable resources are the items that are consumed, the items that are used up as a result of this. So this can be workers. We can only work a worker for so many hours a day, and then we've used up their time, their energy, their resources. Same thing with paper. We can only use so many pieces of paper, and then we've used them up, and then we have to find more paper. The same is true with staples. So these are variable resources. These are changing with the quantity that we're producing, and we're using up those resources. We don't continue to just have them. So think about a pizza restaurant. What are some fixed and variable resources based on what we've seen here that would be fixed? The oven, for instance, would be a fixed resource. Mozzarella cheese, a variable resource. And you get the idea in terms of what's being produced there. Now, Mr. Clifford has a great AC/DC econ video on diminishing marginal returns, what we're going to talk about here. So I would encourage you to check out the chapter notes. There is a link in there to take you to that video. Got a couple others in this chapter as well that I think you'll find helpful. So looking at inputs and outputs, this idea of businesses are here to make money. They have to make something. They have to produce something or provide a service. And so that's how they're going to make money. That's how they're going to make a profit. In order to do this, they're going to have to use resources. They're going to have to use their inputs in order to make these products. And to do so, these inputs essentially are called factors of production. Factors of production are things like natural resources, human resources, people, and capital resources, the machinery and equipment that is used to create these products. These are all inputs. These are all factors of production. So we get the total physical product, or the total product, by taking what is our total output or our quantity produced and subtracting that from this total product. Essentially looking at this in terms of what is our total output? What are we producing here? This essentially is our total product. So how much of it can we make? This is the quantity we're producing. Now, marginal product is looking at how many more additional units, if we add a worker, can we create? How many more units can we produce as a result of adding a worker, one worker? Marginal, again, thinking at the margin, making a decision at the margin. This is the idea of one more being produced. That's marginal product here. So the change in total product divided by the change in inputs. Usually that change in input is 1 because it's one additional worker. So what is the change in total product based on the fact you're adding one more worker? That gives you a marginal product. Average product is just dividing it by the total amount of labor that you have. You look at the total product, divide it by the total labor. That's going to give you your average product. The marginal product is, again, usually going to be divided by 1 because it's only 1 unit change in terms of what's happening here. And so the average product then is that output per unit based on what we see here with the total product divided by the units of labor. Now, in looking at this production, why is it that we hire more workers? What is going to happen to our marginal product? Well, what we're going to see is best if we look at the graph in terms of how this is laid out. But what we're going to find is we're going to experience what we call diminishing marginal returns. We're going to see an increase until we don't. We're going to see an increase in what we're able to produce to a point. And then we're going to experience diminishing returns because we can only push those resources so far. And we can only get so far with adding workers to that assembly line until we reach a point at which it's not cost effective to add those workers anymore. And that's the idea of the law of diminishing returns. As we add additional resources and add them to fixed resources, the additional output produced from each worker is eventually going to reach a point at which it will start to fall. Now, it will increase up to a certain level, but then again, there's going to reach a point at which it eventually does fall. And that's the law of diminishing marginal returns. The idea of too many cooks in the kitchen. And we've seen this all the time, right? Once you have too many people in the kitchen making pizzas, making product, they're tripping over each other. And as a result of this, they're not going to be as effective as they would if they had more room, to actually breathe and maneuver and get things done. So too many cooks in the kitchen is not going to help the situation. That's going to lead to the law of diminishing returns. And that's what we see here in this example. Notice one worker can make 5 links on a chain. 2 workers can make 13. Great. 3 workers make 19. We're already starting to see diminishing returns setting in. The first worker made 5. The second worker added 8 as a result of that. Now all of a sudden the third worker is only adding 6. And then the fourth worker 4. And then the fifth worker only 2. The sixth worker 1. Our marginal product is already diminishing. And now we reach a point at which total product is going to fall. So our 7th worker actually reduces the number of chain links that we're able to create by 3. So now all of a sudden, not only are we experiencing diminishing marginal returns, we also have total returns that are falling as a result of this. So just because we hire an additional worker doesn't mean we're going to add additional product. We will see that up to a certain point, but then we're going to start to experience the diminishing returns effect, and that's going to affect total product as well as marginal product in terms of what we see here. And this is because of the idea of, again, too many cooks in the kitchen. As you add so many workers, there's more confusion around communication. There's more confusion around what resources are available, how many resources are available. Are they all available to each worker, or do they have to specialize in terms of trying to address that? And even then, there's communication issues. So the idea here is we break this down into basically 3 stages of returns in looking at this. When it comes to marginal product, you can see the blue line there. It rises and then it falls. That's our marginal product. Our total product, again, rising until it doesn't, and then it will start to diminish. And then average product is going to rise and fall fairly quickly in terms of the the average product we see here. So our first phase, or our first stage of this, is really increasing marginal returns. We see the total product is rising, it's increasing, and marginal product is too. Everybody's taking advantage of cost savings and efficiency, and everything's starting to do well. Marginal product is rising, total product increasing, and it's because of specialization that they're able to do this, and they're able to do it cost effectively and efficiently in terms of making more product. But that's only going to last for so long. And then what we start to see is in phase 2, we see decreasing marginal returns. Notice total product is still rising, even though marginal product is now falling. We're starting to see diminishing returns taking effect here. It's not going to hit total product because, again, we're still continuing to create more of those links, but we're seeing that total product is increasing at a decreasing rate, at a smaller rate. And that's, we're producing more product as more workers are added, but we're not producing as much product per worker as we were before. And then that is the idea of the too many cooks in the kitchen mentality. Then we get to the third phase, which is the idea of negative returns. Now total product is falling, marginal product is negative, and average product continues to fall as well. So marginal product is negative at this point. So that's where we see total product decreasing all of a sudden. It's no longer increasing even at a slower rate anymore. Now it's falling, and this is the situation in which workers are just tripping over each other in terms of trying to address their production line. And that is ineffective and going to cost your company money and probably some jobs along the way. You don't want to be in negative marginal returns. But that's essentially the graphical element that addresses this type of thing. Now let's look at the data in terms of this. Notice we see the number of workers on the left. We see total product in the second column, marginal product. So total product was that line that we saw at the top here. This is the top graph. Marginal product is going to be this bottom graph, the blue line, that's going to rise quickly but fall just as quickly as it rose. And then average product is, again, we're going to see an increase, and then over the second phase, we'll see it start to diminish as well. And what we see here is, notice total product continues to rise again until it doesn't. It gets about the sixth worker added, or seventh, really the sixth in terms of the 75 pizzas you're creating. Now all of a sudden you added a worker and you didn't gain anything. You're producing the same amount of pizzas. That should tell you that you're not adding profit, you're not adding quality to this mix. So the marginal product then is again the difference between these total products, and we can see here that it is the marginal product is highest here at 3 workers because your marginal product, your gain is actually 20 additional pizzas. That's going to fall off pretty quickly, and then we're not going to see the total product fall until we hit 8 workers. But notice the marginal product already fell after 3, and average product is going to experience it very similarly, in that once you hit 3 pizzas, you've essentially peaked your average product. And so what do we see here? Those 3 stages again, in terms of marginal product peaks and then falls off. Total product is going to go negative by the 8th pizza, and marginal product is long gone by that point. They've experienced negative growth or at a decreasing rate as a result of by the 4th pizza. And we see the same thing with average product. So this is the 3 stages of these returns in terms of total product continuing to rise through the green and yellow levels until it essentially marginal product goes negative. Then that's where total product starts to decrease as well. Now, so more examples of this idea of the law of diminishing marginal returns. Think about when you're studying. You're going to take a test or a quiz or something, and you're studying for this, and you have resources. You have a textbook, you have time in class in order to study for this, but you have variable resources also. You can spend outside of class hours that you can spend outside, and probably a limited amount of them because they are scarce, but you can spend more hours outside of class than you can inside. But there comes a point at which studying isn't going to help you anymore. So the marginal return is very large for the first hour. The first hour that you study is really going to help you greatly. The second hour, it's going to help you, but not as much as the first hour did. By the third hour, you're experiencing even smaller returns in terms of what you're getting out of it. Your return on investment, your ROI, is continuing to fall. And by the fourth hour, you're done. You're bored. You're fed up with this. You don't want to do it anymore. Essentially, you experience negative returns. That's essentially what we see in these stages of productivity. Now, another example: a farmer has 8 acres of corn. He can clear weeds, and if he doesn't clear any weeds, he's going to get 30 bushels of corn. But if he clears weeds just once, through those 8 acres, he can actually get 50 bushels. He can get 20 bushels more than he got if he didn't clear the weeds. Seems cost effective, right? But if he goes through and clears the weeds twice a season, he's only going to get 57 bushels instead of 50. Not quite as profitable for him. Only 7 additional bushels. Doesn't really make a whole lot of sense for him to go through that second time then. And third time, oh mercy, he's only adding 3 bushels. So definitely not cost effective for him there. So going through and clearing it once would make more sense for him to add 20 bushels and then to stop. Don't go through and do that again, because it's obviously not cost effective. And again, here's another great example. If you need another explainer on cost of production, I think you'll find this one helpful as well in terms of trying to practice that. And we'll do a couple of those in class. So we've looked at this idea of short run and long run production costs, and we've talked mainly in the short run. And let's take a closer look at that now, because this idea is that we're short run is not a specific amount of time, okay, in terms of what we're looking at here. And we'll talk about long run here in a second. But this is idea in which there is at least one resource in the short run that is fixed, those fixed resources versus variable resources. So something is fixed. Maybe it's a lease you can't get out of, a piece of machinery you can't sell or can't give back. You're stuck with it, basically. That's an idea of a fixed resource. A fixed cost is essentially something that you just can't get out of. I can't get out of a lease as easily in 2 years as I can in 5, right? And that's where short run becomes long run, because the idea there is, while it is fixed in short run, I can get out of the lease 5 years from now. That's more long run in terms of how that shakes out. So the plant, the manufacturing facility you can't change that in a short run. Yeah, you can add space over time, and you can change that so that you can find another plant that's more size specific for your organization, maybe a better lease agreement, better costs involved. You can't do that in the short run, but you can do that in the long run. And that's really the effect here. So because all of these variables, all these resources are going to be variable in the long run. You can always renegotiate those types of things, but you can't always do that in the short run. And that's really the issue that we're talking about here in terms of the short run, things that are fixed as a result of that. So today we're looking at short run. At the end of this video, we'll look at taking you through the long run of that. So if we look at total costs, we have total fixed costs. This is the idea of FC, which is total fixed costs. We have VC, which is total variable costs. And then we have TC, which is basically adding them both together. If we look at per unit costs, notice the AFC is an average fixed cost. Basically taking the total fixed cost, dividing it by the quantity, that's going to give you your average fixed cost. An average variable cost is going to do the same. You're going to take the total variable cost, divide it by the quantity. That's going to give you the average variable cost. And there's another slide coming up that I think will help break that down as well. So the fixed costs, again, they're not going to change in the short run. We're stuck with them, okay? in terms of what you're producing, you're going to use the same plant, you're going to use the same machinery. There's no change there. Variable costs, that would change. Okay, so rent would qualify as a fixed cost there, where variable costs would be things like labor or electricity, definitely human resources and other materials you're using. Those would be variable. So you can change those costs. You can hire workers, you can fire workers. All of those factors weigh into it in terms of variable costs. And then total costs, essentially you get in adding up fixed and variable together. So your total cost, again, divided by your quantity, is going to give you the average total cost, the ATC. And marginal cost then is going to be if you take the change in that total cost divided by the change in quantity, which usually is 1. So whatever that change in total cost is for that additional resource, that's going to give you your marginal cost. So in this case, if the production of 2 more units of an output increases total cost from $100 to $120, these are 2 units we're talking about. So we're going to divide that change, which is $20, by 2. That's going to give us a marginal cost of $10. And again, all we did was subtracted 100 from 120 to give us $20. And we know that the production is 2 more units, so we're dividing it by 2. So 20 divided by 2 is $10, and that's how we got the marginal cost of an additional output, or these 2 additional units that were created. Again, just a review on average total cost. You're going to divide the total cost by the quantity. So whatever your total quantity is, you're going to divide that into your total cost to give you your average total cost. Average fixed cost, same thing. Take your fixed cost divided by the quantity. That's going to give you your average fixed cost. And the same is true for average variable cost, or AVC. Take the variable cost divided by the quantity. That's going to give you your AVC. And if we look for a second at these calculating costs, notice here you have your variable costs, your fixed costs, your total costs, and notice fixed cost is always going to be the same because it's fixed. So that's not going to change. It's always the same number. So if you ever have to fill that in and they give you a couple of those numbers, you know all of the numbers in fixed cost are the same because it's fixed. It's not changing. Variable cost, definitely changing, and we can see here that that contributes to marginal cost. The difference from 0 to 1 is $10. From 1 to 2 is 7. 2 to 3 is 8, because we're taking the difference from one unit of variable cost to the next unit of variable cost and subtracting them, getting the difference. So our marginal cost, notice, is continuing to, it fell at 2 units of output, and then it's starting to rise again at 3. So our marginal cost definitely dropped there, taking advantage of some efficiencies, but those diminishing returns set in pretty quickly. So the last column then, looking at our total costs, notice that the total costs continue to rise and as more units are being produced, and we continue to see that here in terms of the total cost of production. We go from 10 to 20 to 27 to 35, and it's continuing to rise, and we're going to see that in terms of the total costs that we see there. Now, if you want to pause the video and take a look at some of these in terms of trying to figure out, well, what is the average total cost of 6 units? In this example, you would take the total cost, divide it by 6, and you would get an average total cost of $20. You do the same thing for AFC of 2 units. What is the average fixed cost of 2 units? Well, again, the idea here is your fixed cost is 10, you're producing 2 units, your average fixed cost would be $5. And you can continue to do the same here. And you can start the video again when you're done. But this is a good practice exercise, and you're going to get some of these in the take-home quiz and on the Mind Tap as well. I think you'll find helpful. So remember, to get your ATC, you're adding both AVC and AFC. Okay, so you're adding them both together in terms of getting your ATC, your average total cost. And notice here we see for 5 units, the idea here is average variable cost is $12, average fixed cost is $2. You're going to get an ATC of $14. That's not necessarily going to be true for 4 units. You're going to have to look at what the average variable cost is for those 4 units versus 5. And then the average fixed cost for those units. So you want to calculate those based on the output each time in terms of that, in terms of calculating, in order to see how that breaks down per unit. and in your average for average variable cost. Notice again, you're looking at variable cost divided by your output. That's going to give you, or the quantity, same as output. That's going to give you your average variable cost. So $17 divided by 2 is $8.50. Average fixed cost, again, it's $10, we know is a fixed cost, but you're dividing that by your output. So each time the average fixed cost is going to fall. This is the idea of the spreading effect. It's going to diminish over time because you're spreading it out over more and more units that are being created. How is my oven most effective for me when I'm producing pizzas? The more pizzas I can produce in that oven, the more cost effective it is for me, because that fixed cost is being spread out over many, many, many more pizzas, the more pizzas I produce. So if there's downtime on that oven, then that isn't effective because I'm not using it when I could be making money off of it. And that's why we see in a lot of cases businesses that are open 7 days a week. Why? Get somebody to manage it on a day you don't want to work, because if you're closed, that's an oven and resources that are fixed, and you're paying for those resources. Why wouldn't you be open, making money off of that, and earning money off of those fixed resources? So you definitely want to take a look at that, because that definitely will tell you, hey, I'm losing money here. I need to make more money off of these resources. And that really is where we get to this idea of cost curves that are graphically shown. And if we graphed these out in terms of what we see here, what we would find is we have a marginal cost curve that is taking advantage of cost savings to a point, and then all of a sudden diminishing returns setting in, we can see marginal cost all of a sudden starts to rise, and it creates the swoosh, the Nike swoosh we always talk about. And then marginal cost intersecting ATC at its lowest point will continue to rise, and will continue to rise for the foreseeable future for all of the quantity that's being produced there. It's not going to come back down. And the reason for that is because of what we're seeing here with AVC and ATC. AVC, the average variable cost, has a little bit of cost savings here from 2 to 3 at 8.33, but then they experience diminishing return setting, and all of a sudden variable costs will start to rise. We can see now it's $10 and then $12, and will continue to rise as more quantity is produced. The fixed cost is the only one that falls, and again, that's because of the spreading effect, the idea of diminishing costs as a result of more units being produced. I can spread out how many pizzas are produced in that oven, therefore how cost effective that oven is. It literally costs me pennies to make a pizza in that oven, versus if I didn't use that oven as effectively, it may cost me 10 cents or 12 cents a pizza, as opposed to 2 cents as a result of that. And then the last column is ATC, and this is the average total cost, taking AVC and AFC together. You can always check your work here by using your total cost, dividing it by your quantity to give you your average, or adding up your AVC and AFC, which should add up to ATC. So that's a good way to check your work, looking at your total cost divided by quantity. That should be equal to your AVC plus your AFC. If they're not, then you've done something wrong in terms of calculating that. But that is how we visualize the cost curves that we see here. And there is a key graph coming up where we'll address that. But that's how we can double check our work on those cost curves as well. So as I mentioned, the average total cost curve is taking advantage of the spreading effect. And because the fixed costs, the average fixed cost is spreading out the resources over time, that's going to have an impact on ATC as well. So that's bringing down the total cost. But that's not going to last forever, because variable costs will start to rise at some point. And then we end up with the situation that we see here, where variable costs are rising. Even though fixed costs are still falling, ATC just isn't able to keep it low anymore. And then marginal cost intersects ATC at its lowest point, always intersecting ATC at its lowest point, and then ATC starts to rise as well. So when this intersection takes place, all of a sudden ATC is at its lowest point, MC is intersecting, and MC and ATC will rise together and continue to rise on that upward slope. So that's the result of the spreading effect. Fixed costs can only help you so much because variable costs then kick in. And that's the diminishing returns. The more you produce, variable input is going to reach a point at which they're just not able to take advantage of any other efficiencies, any other cost advantages. So variable costs will start to rise, and therefore the total cost will start to rise as well because of those diminishing returns that we see there. So we have the marginal cost curve, the swoosh that is taking effect here. Again, looking at differences between costs based on products that are being produced. We have the fixed costs that are spreading the advantage of the spreading effect as we produce more items. Each of those capital resources cost us less and less in fixed costs. So we're spreading that out over all of the products that are being produced. And then we have the variable costs that are continuing to rise, take advantage of a little bit of cost-effective savings here. But once MC intersects, they see increasing variable costs because the fixed cost just isn't helping them anymore. As a result of that, the ATC will rise as well. So MC intersecting ATC at its lowest point, ATC will rise, AVC rises, MC rises, essentially those three increasing costs and rising together as more quantity is produced. There's no more efficiencies there in terms of the short run in taking advantage of any cost savings that we see there. So the average fixed costs, again, what we see here, the spreading effect, it's going to get closer and closer to that quantity axis without reaching it, just like ATC and AVC are going to get closer and closer without ever touching because of the fixed costs that are spread out over time. So they're never going to touch, but they are going to get closer and closer, just like AFC is going to get closer to quantity. The same distance here, because this is the difference between variable cost and fixed cost. And we see that fixed cost passed along down here in terms of the savings of the spreading effect. Okay, so if we were to calculate the total cost, variable cost, and fixed cost of the fifth unit, of this fifth unit that we see here, we would draw a straight line and we would see where that fifth unit intersects these lines. Doesn't matter where they intersect over here or over here. We're looking at just the lines that intersect on this fifth quantity. So where is MC? Here. ATC here. AVC here. AFC down here. And what we see is our marginal cost, $20. Our average total cost, $16. Average variable cost, about $14.25 or so. And then our fixed costs, just over $6. So in terms of what we can see there. And again, the idea here is that what we are experiencing are all of the costs, $16 worth of costs. This becomes our profit, if you will, in terms of what it's going to what money we're going to make off it in terms of the cost, and the revenue per item, and depending on what we sell it. But the idea here is your costs and your variable costs are down here at $14, and then your fixed costs down here at $6 in terms of what you're seeing there. Now, what you're passing along as a marginal cost, remember, is $20. Not sure what you're selling it for, if you're selling it at $20 or whatnot. But the idea here is this is what it's costing, the cost differential between your variable cost and your marginal cost per unit. This fifth unit is $6. So this is what leads our marginal cost to be greater than ATC, because while the spreading effect is having an impact on AFC, that $6 cost is still a part of what we are using, what we're paying out a cost to produce that fifth item. So that isn't as effective for us here because those costs are rising. And that's what we see here in this example. Okay, so total cost curves then. You think about fixed cost being a unchangeable over the short run in terms of that $10. Variable cost continues to rise. Total cost rises as well. And what we see here is that fixed cost is the difference from the quantity axis to the fixed cost, from the variable to the total cost. We see that as being fixed cost as well. So a couple of things to keep in mind. Marginal cost, it's upward sloping, and we know that it's going to experience the swoosh. There are going to be cost efficiencies in the very, very near term, but ultimately that is going to lead to an upward sloping cost curve, marginal cost curve. AVC is also going to be upward sloping. Again, it may have a little bit of that swoosh, but it is going to be upward sloping. And AFC is going to be downward sloping because of the spreading effect. You're spreading out those costs over all of those quantity of resources. And then MC is going to intersect ATC at its lowest point. And then ATC and MC will continue to rise, as will AVC in those particular examples. So if you keep those 4 rules in mind, marginal cost curve is going to be upward sloping along with AVC, along with ATC. AFC is going to be downward sloping because of the spreading effect. And MC is going to intersect ATC at that lowest point. That is going to help you in terms of drawing any graphs on cost curves. Okay. Now let's look at some of the shapes of these cost curves in terms of why this is so swoosh oriented, right? In terms of that up and down, or that down and up. Notice the marginal product that we talked about earlier was your quantity of labor is helping to produce more output, but it's only going to reach a point at which then it's going to diminish. Diminishing returns are going to set in, and the marginal product is going to fall. Well, think of marginal cost as the opposite of that. So it's the upside down swoosh in marginal product. In marginal cost, it's the upward sloping swoosh, if you will. So you're taking advantage of cost savings here, but eventually those marginal costs start to rise as those variable costs start to rise, as we saw with the marginal product continuing to fall, and ultimately that going negative. So they are mirror images of each other in terms of additional resources or labor being added here. It's only going to have a significant effect in terms of total revenue and your ability to continue to be more profitable up to a certain point. And then you're going to experience diminishing returns. And that's what we see there. So that U-shaped curve essentially is, if we have total costs worked in there and marginal product, again, we can see it peaks here at 8, and then it's going to fall, even though our total product is going to go all the way to 26. It's not even going to fall off in this example in terms of what we see here. But the marginal cost, again, in terms of item to item that we address here, again, a difference of 10 divided by 5, your marginal product, in terms of what you're producing here is $2. You're going to experiencing cost savings all the way up to 3 workers, $1.60. And then all of a sudden at the 4th worker, your costs explode. And then they go past what you saw here to $2.50, then $5, then $10. So you can see some cost savings in the short term there, but then we see that swoosh start to kick in, and marginal costs will start to rise, as we see here in that example. So adding the first 13 units is going to be helpful in terms of what's being produced here, adding that additional worker. But what we're going to see is after adding that 3rd worker, we're not going to experience any marginal cost savings in terms of that production. We're gonna be at a maximum in which we're actually going to lose money as a result. Marginal costs are going to continue to rise. We're paying for additional workers as a result of this. This isn't going to be cost effective. There is a point at which there's too many cooks in the kitchen, and that's what we looked at earlier. So as production continues, each worker is going to add less and less to production, such that the marginal cost for each unit is going to increase. And we definitely see that playing out here with the 4th, 5th, and 6th workers that are added in that example. If we look at this idea then of marginal cost, again, the swoosh, upward sloping, and ATC, why does it go down then up? Because of this idea of taking advantage of economies of scale, efficiencies. Think about it in terms of your marginal cost. If it's below average, it's going to pull the average down because you're taking advantage of those efficiencies. You're able to do that in a shorter quantity, a smaller quantity. You're able to do it more cost effectively. But even with Walmart, there's only so low that you can go, and then you can't go any further. So you have to see that the costs are starting to rise. And that's the issue here, is that the marginal cost, as it starts to rise, is going to pull up ATC as well. And the average is going to rise with it as well. So remember, marginal cost is intersecting ATC at its lowest point. And once it does that, ATC and marginal cost are both going to rise as a result of this. So if you have an average income in the room of $50,000 and all of a sudden Bill Gates, billionaire, walks in, what happened to your average income? Well, it exploded. It took off, right? Why? Because Bill Gates, a billionaire, just came in with his average income, and it really is the rising tide that lifted all boats. Well, the same is true of costs. If the marginal cost is greater than the average, it's going to pull it up. And this is exactly what we see play out here. And the idea is the same. If you're taking advantage of marginal costs, and you can see those efficiencies in the short run in terms of what we're seeing here, that's going to pull down the average because you're taking advantage of those efficiencies. But it's not going to last forever. Think about your GPA. Okay, you get a GPA and it's going to be lower than your overall GPA. What's going to happen to your overall GPA? Well, of course, it's going to bring it down because it's lower. What if it's higher? Well, it's going to bring your GPA up. And the same is true of the relationship between marginal cost and average total cost. They're going to do the exact same thing because if the marginal cost is greater, it's going to lead to a greater average total cost. And if the marginal cost is smaller, then because of those efficiencies, average total cost will be smaller as well. And that is true of the semester GPA example that we saw here. Okay, so some practice with cost curves, and there's more examples in the chapter notes for you to address here. We don't have time to go into all of them, but we could look at 3 things that are wrong with these cost curves as well as 3 things that are right in terms of addressing these, and you could look at them. Remember, ATC is above ABC, so there's one thing that's wrong. Remember, MC is intersecting ATC at its lowest point, right? And ABC is going to be beneath ATC. Once MC intersects ATC, the ATC should be rising. ABC, very similarly, in a lot of cases, we see MC intersecting ABC at its lowest point, but it's again going to be beneath ATC in terms of that rising. And we don't have the AFC in here, but we would see it slowly. We would see it slowly falling and getting closer to the quantity axis as a result of what we see there. Now, let's look at one more example before we move on, and that is at 100 units of a firm's output, the average total cost is $10, okay, is $10. We kind of see that here. And the average variable cost is $8. Fixed costs are $2, and marginal cost is $12. How will each of the following change as the firm's output further increases? Well, best way to look at this is to draw the line at 100. If we move beyond that quantity, which is what they're talking about here, if we move beyond that quantity, what are we going to see? Well, we're going to see AFC falling. We're going to see ABC, ATC, and MC all rising. Why? Because as more quantity is produced, these are increasing because of diminishing returns setting in. AFC is falling because of the spreading effect, but AVC, ATC, and MC all rising as a result of this. Now, what would happen if we decrease the quantity? Well, that's a little different. We could look at these situations in a quantity that's smaller, and we could see that you may have a lower AVC, you may have a lower MC and ATC as a result of that. But again, when in doubt, you should graph it out because that really is helpful in terms of trying to address it. And this is the key graph 29, in terms of typical cost curves that we see here. Notice, again, the swoosh of marginal cost, taking advantage of some efficiencies, but again, continuing to rise. Marginal cost is going to intersect ATC and AVC at their minimum points. So you're going to see ATC and AVC intersected by MC, by marginal cost, and then all of them will be rising. Marginal cost will be rising, ATC will be rising, AVC will be rising. AFC, again, if we had it in here, would be falling and getting closer to the quantity axis because of the spreading effect as a result of that. And that is essentially your typical cost curves key graph. Okay, now let's switch gears as we close this out. Let's take a look at Okay, so we've been talking about everything in the short run in terms of fixed costs that can't be varied. Now we're going to shift to looking at the long run in which all costs are variable. There are no fixed costs. Everything is variable in the long run because, again, like we talked about with leases or rental agreements, all of those things can be broken in the long run. They can't be in the short run. I signed a 2-year lease. I'm stuck with 2 years. But in the long run, I can still I can still renegotiate. I can find a new place to go. I have lots of options. Okay. And so this is what leads us to this idea of economies of scale. And again, thank goodness for Mr. Clifford, another explainer on economies of scale. Check out the chapter notes and the link there, or Google on YouTube, economies of scale, ACDC econ. To get that. But he's going to talk about the exact same thing we're talking about here. So if you need another explainer, hopefully you'll find that helpful. So in the long run, remember the idea here is that the short run and long run aren't specific amounts of time. We're looking at them, and students always want to, like, how long is short? How long is long? What are we talking about here? It's not about amounts of time. It's about what costs change over that period of time, and there's no specific amount. For one situation, the long run may be a year, where in another situation the long run may be 5 years. It just varies depending on the situation. So you always have to look at the scenario and the terms of what you're looking after in these particular situations. So remember, in the short run, you have an idea here that at least one of the resources you're using has fixed costs. There's something you can't get out of, and you're stuck with it. Okay, so you can't change the size of your factory in the short run. You can in the long run. You can renegotiate. You can find a new factory, whatever. But you can't do that in the short run. Okay, so you're stuck with it. But remember, in the long run, all of those resources are variable. So all costs are variable in the long run. And so that's the beauty of long run. That is a little different and gives you other options than short run in terms of what we see there. So why is this so important? Because you can do a lot more things in the long run when you have more flexibility in terms of taking those fixed resources and making them variable, finding other options in order to address it. So that's what we see here in this idea of returns to scale. And this gets into the idea of economies of scale. So we're going to assume that you're producing televisions in a factory. Okay, you're making TVs. And if you're doubling your inputs, and again, inputs being workers, tools, machines, what 3 things could happen to your output? Well, in looking at this, if your output more than doubles, you could experience increased returns to scale. The idea of efficiencies in that you're able to take more advantage of resources and innovations with those resources and technologies, that you're able to do more with them. You could also see a constant return to scale in which you're able to do that for a short period of time, but as you produce more and you add more resources to the quantity that you're producing, all of a sudden you're experiencing, you're still returning to what we call constant return to scale. You're making money, but not as much money as you were before when you had increasing returns to scale. And then the last version is when your output less than doubles, and all of a sudden you're experiencing higher costs and you're not able to make your money back. So you're actually losing money as a result of this. This is what we call decreasing returns to scale, or diseconomies of scale. And it's not where we want to be. This is where businesses start to take a look at their bottom lines. They start to question their executives. They fire some of their executives because they're like, what's going on? Why didn't you pay attention to this? And why haven't you moved us back to item number 1, where we want to be? Increasing returns to scale and doing that effectively all the time. That is really the big difference here in terms of what we're experiencing. So increasing returns to scale, constant returns to scale, and decreasing returns to scale are really what we're looking at here. And again, we're looking at this in terms of production, not just costs, but we are looking at this in terms of how efficient is this making our resources in terms of being able to produce more and to produce it effectively. Okay, so in the long run, what's going to happen if we increase our capacity? Well, we could work out of our garage, right? We could rent out a building and add more workers and add more saws. We could rent a factory, right? And buy more saws, hire more workers. These are three very different scenarios in which we see very different returns to scale. Okay, either constant, either increasing or decreasing, and we could also build our own plant, and then use robots and other types of technology in order to create this. So there's lots of ideas that you can do here in terms of creating ways to be more innovative and more effective, and all of these are short run solutions to try and innovate and be more creative. So if we start in our garage and we move to a building, which we're and then to a factory, each one of these is more efficient than the last one. So we're essentially moving to an increasing return on our investment because we're basically finding new ways to be smarter, more innovative, and more cost effective with the resources that we have, and to produce more as a result of that. So it does benefit us for a time, and then we have to find a new way to be more innovative. And this is why you see companies with marketing and advertising campaigns and finding ways to do more things cheaper, smarter, faster, more effectively, and more cost effectively, because they're trying to take advantage of this idea of moving along the long run. In terms of their average total cost. So why do we look at this idea of economies of scale? Well, again, if a business can do this and do it effectively, they can continue to make money and they can continue to grow and produce more product, and again do it more technologically savvy and be more effective as a result of it. So if a car company is making 50 cars and they have a high average cost per car, they can produce more cars and have a lower average cost per car if they're taking advantage of economies of scale, if they're using more technology to do so. And then using these robots and other technologies today is going to help them do more with less as a result of this and increase their economies of scale. So what does this look like then? Well, the long run average total cost, we can see what we're talking about here, what we've seen in the visual, is more of a short run. The idea is that we're experiencing lower average total costs, and then there's going to come a point at which this should be intersecting the minimum of ATC, and then all of a sudden costs are going to rise, right? Well, we don't want to continue to rise with these costs. We want to take advantage of the fact that we have been doing such a good job of being innovative. We want to be innovative again and keep this going downward. So we find a new way to push out the quantity produced, and finding a new factory or new technology or new resources to do it more innovatively. And now we've created a new short-run average total cost curve. And that short-run average total cost curve, notice marginal cost continuing to creep there a little, but it should be intersecting ATC at its lowest point. But again, we don't want to go up the marginal cost 2 or the ATC 2. We want to innovate because if we don't, again, we're going to experience increasing costs, and then our business is going to see less profit and more costs, and that isn't what our shareholders are going to be looking for. So again, we want to go to MC and ATC 3, in which we found a new factory or a new technology or a new way of doing things that again shifts out that curve into a new ATC 3. Which again takes advantage of new efficiencies. And what we're doing is we're creating a slope, essentially. We're creating a slope here, our marginal product of labor, that is creating a long-run average total cost curve made up of all of the left side of these SRATCs, or these short-run average total cost curves. And you'll see the visual here in a moment. Now notice we didn't take advantage of ATC 3 as well as we probably could have, so we had to jump over to ATC 4 at a point where ATC was rising and was actually getting higher. We didn't like that. And we don't want to experience that. So we jump into ATC 4, a new technology, a new innovative resource, a new way of doing things. And what we're doing is trying to bring us back to increasing returns to scale. Now, it wasn't as effective as it was back in ATC 1 and ATC 2. So this is leading us to this idea of constant return to scale, where it's as low as we can possibly get it. We're producing 100,000 cars. Think of Tesla in this model, right? They're continuing to ramp up and produce more cars. They're trying to do them in a way that is cost effective and profitable for their shareholders. And just because they're adding more quantity doesn't mean that they're adding more profitability. Their costs continue to rise. They're experiencing diminishing returns. That's what we see in this example. And so notice ATC 5, well, all of a sudden, we're not at the same place where we were back at ATC 1 or 2 or even 3. Our costs are rising now. We're producing 1 million cars, but we're certainly not producing it at the same average total costs that we were back in ATC 1, 2, or 3. These costs are rising now. And this is leading to our diseconomies of scale over here. The firm is too big. It's too hard to manage. It's too hard to deal with. The costs are rising. We're not able to get a handle on it. A lot of times this is a situation in which if you can't bring it back to economies of scale, then the shareholders look for new leadership. Let's get a new CEO in there. Let's get a new chief executive officer or a new president or a new chief financial officer, somebody to help us bring these costs back into line. We saw this at McDonald's, actually, where this was happening, diseconomies of scale kicking in. And all of a sudden, they fired the CEO and hired somebody new. And what are they doing? They're going back to basics. They're going back to trying getting their economies of scale back in check again. So what do we see here? Well, what we see is overall, if we look at the left-hand side of each of these ATCs, we're going to see that it's creating a long-run average total cost curve, an LRATC, standing for long-run average total cost curve, made up of the left-hand side of all of these average total cost curves, for the most part. A little too much on ATC 4 there, right? So what we see is this red line, this red curve, creating a much larger long-run average total cost curve in which everything is variable, but we can't stop those costs from rising. So what this gets us to is this idea of economies of scale. We're able to take advantage of cost savings, innovation, new technologies, but it's only going to go to a point at which then we are experiencing the constant returns to scale. No matter what we do to try and innovate and create and bring in new product or change factories or whatever, or new technologies, we're only bringing in constant returns to scale. But notice we've gone from 1,000 cars being produced to 100,000. So that's not chump change. That's not to say that we're not improving on the product, but we just can't bring down costs. And this is where we have to find a new way to do it, or otherwise we end up in this space over here, diseconomies of scale. And this is, again, where shareholders call for new leadership. They call for a new CEO. They fire the old one or fire the management team and bring in new people to try and get us back to this left-hand side of economies of scale. So this is the idea of the long-run average total cost curve in terms of that experience of economies and diseconomies of scale. I always use the Walmart example here because Walmart continues to bring prices lower, but there's only so low that they can go. And then all of a sudden costs start to rise. And LRATC is very similar to this. There's only so far they can go on this track. And especially at this level, when you're producing 1 million cars, of course you can't produce it at the same costs that you could 100 cars. It's a different world in terms of what you're being produced there. So to simplify the LRATC, this isn't a key graph, but maybe it should be. The idea here is on the left-hand side, when we're taking advantage of innovation and technologies, we see economies of scale. Where it levels off, we see constant returns. And where the costs start to rise on LRATC, we see diseconomies of scale. That's usually a leadership or a management change in terms of that being addressed. But again, in the long run, why are we looking at the left-hand side of all of these ATC curves in the short run? Because there are no fixed resources in the long run. So with all of those resources being variable, we can change things up. We can change factories. We can change workers. We can change the technology we're using in trying to get us back to economies of scale. And many businesses can do it that way and can be effective in doing so. And sometimes bringing in new leadership really does help in terms of bringing them back to that economies of scale. But it's not always effective. And that's the point that they're making here. Again, another version. This is from your Krugman text in terms of that economies of scale, diseconomies of scale. Notice constant returns is essentially a point, a plotted point on that particular curve in terms of what we see there. And again, there's always trade-offs, right? In terms of what you're doing in terms of fixed costs that may be higher or lower in terms of trying to address it. But the idea is as output is continuing to rise, it's really hard to manage costs. And so while your average total cost is lower, the higher amount of fixed costs is going to have an impact on that as well. And that's what we see here in this particular example. As output goes up, again, your average total cost is going to be lower with the higher amount of fixed costs that you have, because there's only so much you can do with those higher fixed costs as a result of that. Okay, well, I hope you found this helpful, especially as we go from short run to long run and looking at those cost curves: marginal cost, fixed costs, variable cost, average total cost, average fixed cost, average variable cost, all of these key terms. Make sure you know the language. Remember, we said economics is speaking the vocabulary, and it is never more important than in this chapter because there's a lot of terms here to know. So make sure that you go back through those, and hopefully you'll find those helpful. Okay, in our entrepreneurial moment, let's take a quick look at applying this to your business, looking at costs, what costs would affect your business, how would it affect what type of business you actually chose to open, and how might those costs change over time. We definitely saw that in today's analysis of the concepts of short run average total cost versus long run average total cost and the differences that we see taking shape there. So those costs definitely do change over time. Now, how is that going to lead to a different experience for you and your business? The fixed costs that your business would have, depending on the type of business you have, versus the variable costs, and then your total costs in terms of what you would incur. And think about it in terms of the type of business you would open. Maybe it's a plant store, maybe it's a pizza shop, a coffee shop, a donut shop, whatever the case may be. And how that affects your total costs, your fixed costs, and your variable costs. And remember, your total costs should equal your fixed plus your variable. And then how would it affect the way you do business? Are these costs going to eat you alive to the point that you're not making a lot of money? You have a really marginal business, and as a result, you could go out of business as a result of this. Many businesses today are going out of business because of coronavirus, because of COVID-19, and they were on the margins before coronavirus hit. It impacted them hard. It really impacted them hard and had a negative impact, and as a result, they're not with us today. So this is where planning is so important in entrepreneurial endeavors. It's really important that you plan, because failing to plan is a plan to fail. And I talk to business owners all the time. Unfortunately, I see a lot of them really struggling to make it today in this environment, and really working to keep their customers because of how hard it is. And going back to these cost curves is really critical in that line of work, in that line of business. Okay, some cost curve examples from your take-home quiz study packet. Here are the answers to those. And again, we have posted the answers with explanations on my MCPS Classroom, so hopefully you can find those and bring those with you to class on Friday so we can talk all about them. Those cost curves, those costs that you see there, how to calculate those costs. These are really great questions for a quiz or a test or even the AP exam. Hope you found this helpful, and you can always pause this and use this or use the one on my MCPS Classroom. I hope you found this helpful in this overview of the chapter 12, chapter 8 in the hard copy textbook, chapter 12 in the online version. And we will see you in chapter 13 as we take a closer look at perfect competition, production, and profits as we look at the industry supply curve.